the next thing that we have to look at. Again, I think this stuff is going to be really easy. I think you've seen it before. Let's talk about reflections. So if I'm looking at this rectangle here and I want to reflect this rectangle, I need to be told how I'm reflecting the rectangle. As you can see, I've drawn this line x equals 0. And what we're going to do is just reflect across this line. So essentially, the way we want to think about this is the distance away from the reflection line, in this case, is the difference between -2, our x value, and the value x equals 0. So if I want to reflect this, my d prime value is just going to be the distance from -2 to 0, which is 2, and my y value doesn't change. So you can imagine that this value is going to do the same thing. So the distance from -4 to x equals 0 is 4, and then y stays the same. So I know you could do this also visually just by thinking about this as though it's a mirror. Okay, but we want to go a little bit deeper than that. So this is going to be C prime and B prime. Okay, so let's say instead of reflecting about the line x equals 0, what if I wanted to reflect about the line, I don't know, can we fit it? Let's say y equals -1. Okay, so what if I want to reflect about the line y equals -1? Well, I'm going to do the same thing. So I have to look at each of these values. Let's take, for instance, let's take our a value. And what we're going to do with a is we have to find the difference between the y value, 3, and the line that we're reflecting it about, right? So essentially, it's going to be 3 minus -1, because I need to find the difference between 3 and -1. And then I'm going to take that many units from that line. So for a prime, I'm going to go down 1, 2, 3, 4 units. And again, in this case, my x value is going to stay the same. Okay, and we do the same thing for b prime, noting again that the x value stays the same, but the difference between -1 and 0 is 1 unit. So we need to move it down another unit. Okay, C prime is -2, -2, and D prime is -2, -4. Again, this is easy to see visually, but I think it's important to talk about how we would calculate these things. All right, so now for a moment, I just want to take us to GeoGebra. So you can write this in your notes, but what I want us to do, I'm just doing this here because it's easier for me to see. Okay, so let's start with this line here. So what happens when we reflect, and as you remember, this is our parent function. This is a parabola. It's got all these points, which I'm actually going to take out of here for purposes of making it look nicer. Okay, so what happens when we reflect this parabola about this line? Well, I think you can imagine. So I'm going to take this object and reflect it about this line. And don't worry about that equation, but you can see that all the y values have stayed the same, but the x values have moved a distance away from x equals 1 on the other side. So if you want to take a minute and jot this down in your notes, that would be great. All right, so let's get rid of x equals 1. And I just want to show you what happens when we reflect about the line x equals 0. So as you can imagine, if I take my parabola, okay, and I reflect it about the line x equals 0, there's no change. So this is what I mean by an axis of symmetry. This graph would fold over itself if reflected in the line x equals 0. Okay, so let's ignore that one for the next example. And so what happens when we reflect a line that goes through the parabola? Exactly the same thing, except part of the parabola will be above the reflection line. It's going to look like this. Again, you can ignore the equation. Okay, and the last one, guys, this is the most important one because this is the one we're going to be doing a lot of for the rest of the unit. So, what happens when I reflect across the line y equals 0? Well, as you can imagine, this thing is just going to do what we call a vertical flip. Okay, so it's going to look like this. So we're going to be spending some time talking about vertical reflections of parabolas, and that's coming up next. So please jot this down. And we're going to go back to this guy. If you want, you can pause the video and jot that down. One last point to make about reflections is that, again, you don't always need to have the graph. So let's talk about if I was given these 4 points, what I would do if they were reflected in the line x equals 0. Well, we know that the distance away from x equals 0 is just, for example, for A, we have 0 minus -2. We know that that difference is 2. So basically, I know in all of these, my y value is going to stay the same, and my x value is the difference between the x coordinates and the line x equals 0. So in this case, I get 0, -2, 2, 3, and 16, 0. So for the next one, I want to reflect in the line x equals 2. And so if I picture that, I have a point and I need the difference in x values, okay, here to here, and then I have to add that to 2. So in this case, I have 2 subtract -2, which is 4, and then I have to add 4 to the x equals 2 value for my new x coordinate. So I'm going to get 6, and again, our y values stay the same. In this case, I'm going to get 4, -2, and I got that by taking 2 subtract 0 and then adding it back to the 2. And in this case, I'm going to get 6, 3. 2 subtract 16 is 18. 18 plus 2 is 20, 0. Before we move on to C, I just wanted to try to make a general rule about A and B and how we got our translated image values. So if I take B as an example, basically my y values stay the same, but my new x values end up being 2, and I'm getting this 2 from here, plus the distance from 2 to the x values. So it would be, for example, 2 minus x. So in this case, if I call these values, these highlighted values, x, I know that my translated image is going to be 2 plus 2 minus x. Now if we go back to A, it's actually way, way, way simpler because I'm right at, there is no offset from the y-axis. All I have to do to get my new values is multiply my x values by -1. So as we approach our last example, which is a very important example because this is what we're going to be doing for the remainder of the unit, if I think about reflecting anything in the line y equals 0, which is obviously the x-axis, right? So no matter what it is, all I have to do, right, is basically flip it. So I'm going to look at flip it vertically, I should say. So all I have to do is look at all my y values, and I'm going to take them and I'm going to multiply them by -1. So when I reflect along the x or the y axis, my calculation becomes really, really easy. Okay, so we can say in this case that the general rule is we take all our y values and we multiply them by -1 to get what I'm going to call my y prime values. And my x prime values are just my x values, they don't change. So just a couple more comments. Translations are slides, okay, and they happen by changing h and k. Reflections are, we can call them flips, flips, and in this case, in this unit, in this course, we're only going to look at vertical flips. So if I were to have, you know, a parabola that looks something like that, okay, so really the only thing I can do is I can translate it, okay, by changing h and k, or I can flip it vertically. Okay, so this would be a reflection. Or we call this a vertical reflection. So I think we can move on.